Imagine a car where the battery is not inside the vehicle, but is the vehicle itself. For over a century, every automobile followed the same invisible rule: a rigid structure carrying components, an engine mounted inside, a fuel tank tucked away somewhere in the chassis. Everything had its place. But something strange is happening in the electric era. Cars are getting heavier, more complex, less efficient than they were supposed to be. And it raises an uncomfortable question. What if the problem was never the battery, but where we chose to put it? And what if the solution doesn't just improve the car, but replaces it entirely? To understand why this idea is so radical, we need to go back, not to electric vehicles, but to the very foundation of what a car actually is: the original architecture. Early automobiles were brutally simple: a ladder frame, a heavy, rigid structure designed to tammel everything. On top of it, engineers mounted the essentials: an engine, a transmission, a fuel tank, a body. Each component had a clear role. The structure carried the load, the engine produced power, the fuel stored energy. Separate systems, separate responsibilities. It was inefficient, heavy, but it worked. The shift to unibody. Then came the next evolution: the unibody. Instead of a separate frame, the body itself became structural. Panels weren't just cosmetic anymore, they became load-bearing. The car became lighter, stiffer, more efficient. And for decades, this became the dominant philosophy, not just because it worked, but because it aligned perfectly with the internal combustion engine. The ICE constraint. Internal combustion engines imposed constraints: large engine bay, transmission tunnel, exhaust routing, fuel storage. Every car had to be designed around these elements, and so architecture was never truly free. It was dictated by the engine. The EV revolution. That wasn't then. Electric vehicles arrived, and for the first time in history, the engine disappeared. No crankshaft, no gearbox, no exhaust. This should have been the moment everything changed, a chance to completely rethink what a car could be. But that's not what happened. The skateboard compromise. Instead, the industry chose a shortcut: the skateboard platform, a flat battery pack placed under the floor, motors at the axles, a body mounted on top. It looked revolutionary: low center of gravity, better packaging, simpler layout. But underneath, the philosophy hadn't changed at all. The battery was still just a component, a heavy one, a massive slab of energy, being carried by a structure that already existed. And this is where the problem begins. Because now, electric cars face a paradox. They are supposed to be simpler than combustion vehicles: fewer moving parts, less mechanical complexity. And yet, they are often heavier, bulkier, structurally redundant. Why? Because every modern EV is built with two systems doing the same job: a structural chassis and a battery that contributes nothing to structure. Two systems, one purpose. And that is where the inefficiency hides. Not in the motor, not in the chemistry, but in the architecture itself. And this is where the story becomes uncomfortable. Because the electric car, the machine that was supposed to simplify everything, may have inherited a problem it was never meant to carry. The weight that shouldn't exist. At the heart of every electric vehicle lies its most critical component: the battery. It is not just a fuel tank. It is not just a storage device. It is the single heaviest element in the entire vehicle. In many modern EVs, the battery alone can account for 25, sometimes even 40% of the total mass. Think about that for a moment. Nearly half the vehicle does nothing but sit there, storing energy. And here's the contradiction. That weight does not help the car stand. It does not reinforce the structure. It does not improve rigidity. It is carried, like cargo, dead weight. In engineering, there is a principle that quietly governs every efficient design. If something has mass, it should serve a purpose beyond existing. The battery violates that principle completely. The redundancy nobody talks about. Now look deeper. Every modern electric vehicle is built with a reinforced chassis, beams, crossmembers, structural rails. Their job is simple: carry loads, absorb impacts, maintain rigidity. Now look at the battery. A rigid, dense, rectangular structure placed inside that same chassis, protected, encased, isolated. So what do we actually have? Two separate systems, both designed to handle forces, but only one of them is allowed to do it. The chassis works, the battery waits. This is not just inefficient, it is fundamentally redundant. Imagine building a bridge and then placing a second equally strong structure on top of it that is forbidden from tammel any load. That is what modern EV architecture looks like, and the consequences ripple everywhere. The energy paradox. Now the problem compounds. Because range matters, consumers want more kilometers, more distance, more freedom, and the only way to achieve that is to add more battery. But adding battery means adding weight. And adding weight means higher rolling resistance, higher energy consumption, lower efficiency. So engineers respond the only way they can. They add even more battery. And suddenly the system enters a loop, a vicious cycle. More range leads to more battery, leads to more weight, leads to less efficiency, leads to more battery. This is not progress. This is compensation. And this is where the industry quietly hits a wall. Not because batteries aren't improving, but because the architecture surrounding them is holding them back. The illusion of optimization. For years, the focus has been clear: better chemistry, higher energy density, faster charging. Companies have invested billions trying to improve the battery itself. Tesla pushes energy density and manufacturing scale. BYD optimizes cell packaging and safety. Toyota explores solid-state breakthroughs. But what if all of that is only half the equation? What if the real inefficiency is not inside the battery, but around it? Because no matter how advanced the chemistry becomes, if the battery is still treated like cargo, the system will never be truly efficient. The forbidden question. And this leads to a question that for decades engineers avoided, not because it wasn't obvious, but because it was dangerous. What if the battery should not be carried at all? What if the heaviest component in the vehicle was never meant to sit inside a structure, but to become the structure itself? Because if that were true, then everything we know about car design, from chassis to crash safety, from manufacturing to repair, would have to change completely. And this is where the story shifts from optimization to reinvention. And this is where everything changes, because instead of making the battery better, some engineers started asking a different question. Not how do we improve it, but why are we using it this way at all? The idea that breaks the rules. For decades, one rule remained untouched in automotive engineering. The structure must protect the battery. The battery must never be structural. It made sense. Batteries are sensitive. They react to heat. They can fail catastrophically. You isolate them. You protect them. You never build around them. But what if that rule was the problem? Because once you remove it, a completely different architecture becomes possible. Instead of placing the battery inside the car, you make it part of the car, not a passenger, not cargo, but structure. When energy becomes structure. This concept is known as structural battery, or more specifically, cell-to-body architecture, and the idea is deceptively simple. The battery pack is no longer enclosed within a frame. It becomes the frame. Cells are arranged, bonded, and integrated directly into the vehicle's body, not just electrically, but mechanically, which means something radical happens. For the first time, the battery begins to carry load. Forces that once traveled through beams and rails now move through the battery itself. The load path changes completely. Instead of structure to protecting battery, we now have battery to becoming structure, and that single shift eliminates an entire layer of redundancy. Engineering breakdown. Now this is where it gets interesting, because turning a battery into a structural component is not just design, it's physics, materials science, and risk colliding. Load distribution. In a traditional car, forces flow through rigid metal structures, steel, aluminum, reinforced frames. In a structural battery system, those forces are redistributed across the battery pack through cell casings, structural adhesives, composite enclosures. The battery is no longer protected from stress. It participates in it. Structural bonding cells are no longer loosely packed modules. They are glued, compressed, integrated into a unified structure. Think of it less like a box of components and more like a solid block, a stressed member. This increases rigidity, reduces flex, and allows the entire vehicle to behave as a single, cohesive unit. Material innovation. Traditional chassis rely heavily on metal, but structural batteries introduce new materials, advanced adhesives, composite reinforcements, hybrid metal polymer systems. The goal is not just strength, but controlled deformation. Because in a crash, you don't want the battery to be rigid, you want it to absorb energy without failing. Energy plus structure integration. And here's the real breakthrough. The battery now serves two roles: energy storage, structural support. This is something traditional engineering tries to avoid, because combining functions introduces complexity, risk, uncertainty. But when done correctly, it unlocks something extraordinary. The vehicle becomes lighter, because redundant structures are removed, more efficient, because less mass needs to be moved, and more rigid, because the entire body works as one. Real-world execution. This is not theoretical. It is already happening. Tesla has introduced structural battery packs integrated with large front and rear castings. BYD developed cell-to-body systems where the battery directly contributes to structural rigidity. These are not small changes. They redefine how a car is assembled. Fewer parts, fewer joints, fewer failure points. Entire sections of the vehicle collapsed into a single integrated system. And this is where the shift becomes undeniable. Because once the battery becomes structural, you are no longer designing a car. In the traditional sense, you are designing a system where energy and structure are the same thing. The moment of realization. And this leads to a realization that is both exciting and deeply unsettling. If the battery is the structure, then what exactly is the car built around anymore? Because for over a century, the answer was always clear. The engine defined the vehicle. But now, the battery is not just replacing the engine, it is replacing the structure. And when that happens, you are no longer evolving the car, you are redefining it. And this is where the industry begins to split. Quietly at first, then all at once. Two philosophies, one future. On one side, Are the companies refining the old world, vehicles built on skateboard platforms, batteries protected, structures unchanged? A familiar approach, predictable, proven, safe. On the other side, a different philosophy is emerging. Tesla is collapsing structure and battery into one unified system. BYD is integrating cells directly into the body itself, not optimizing the car, but redefining it. And the difference is profound. Traditional EVs are assembled. Structural EVs are integrated. Fewer parts, fewer connections, less mass, but also less separation between systems. And that changes everything. Manufacturing, the hidden revolution. This isn't just about engineering. It's about how cars are built. When combined with technologies like gigacasting, entire sections of the car can be produced as single pieces. No welding, no layering, no complex assembly chains. Factories become simpler, faster, more automated, but also less flexible. Because when everything is integrated, nothing can be easily separated. And that leads us to the part of the story the industry doesn't like to talk about. The dark side. Because every revolution comes with a cost. The crash problem. If the battery is the structure, what happens in a collision? In traditional cars, damage is absorbed by crumple zones. Structural elements deform, while critical components are protected. But in a structural battery system, the most critical component is part of that structure. Now imagine an impact, where the battery itself tackles the force, not just damage, but deformation. And suddenly, the question is no longer about repair, it's about safety. The repair nightmare. In today's vehicles, you replace a panel, a beam, a module. In a structural battery vehicle, you may be replacing everything. Because if the battery is compromised, the structure is compromised. And if the structure is compromised, the car is gone, not repaired, replaced. The risk. Nobody can. Ignore batteries are not passive components. They store immense energy, under pressure, under heat, and when they fail, they don't fail quietly. Now imagine that system, not isolated, but embedded into the very skeleton of the vehicle. The same component that holds the car together is also the one that carries the greatest risk. And this is the trade-off. Efficiency in exchange for complexity. Integration in exchange for consequence. For over 100 years, cars were built around their power source. Engines dictated layout, fuel dictated structure. Everything revolved around combustion. Even when electric vehicles arrived, the architecture remained familiar, recognizable, safe. But now, something fundamental is shifting. The battery is no longer just replacing the engine. It is replacing the idea of what a car is. Not a machine built from separate parts, but a unified system, where energy and structure are the same thing. And that changes the rules, because when the most important component is no longer something you install, but something you build everything around, you are not designing a better car. You are designing a different one. And the question is no longer how far electric vehicles can go, but how far this idea can reshape the entire industry. The car, as we knew it, may already be gone.